Okay, for question 12, part B, okay, let X be a binomial distribution. Okay, the n is equal to 5, and the probability of success, that is kicking a goal, okay, and score a point, okay, the goal is 0.8. Okay, now it is, so X is the number of goals that you score out of the 5 goals. Okay, so every time when you read the question, you have to be very, very careful, because they use a different word. In this question, they say 3 goals. Then miss twice. Okay, the word then means follow. That means the first kick is a goal. So it's a yes. Second one also get in. Third one also get in. But the fourth one, no. And the fifth one, no. So that means then. So there is only one outcome. So you have to be very careful with the word then. That means one after another. That is the meaning of then. Okay, so then you got 0.8 to the power of 3 times 0. Am I right? No. Yeah. 0.2 to the power of 2. But if the question say probability of 3 goals, and miss twice, so this means that you can use probability of X equal to 3, any 3. So you can use binom PDF. 5, 0.8, and a 3 here. Then you get the answer. Is that fine? Okay. So you have to be very, very careful. The word that they use. And they use then and it make a vast difference in statistics. Okay, let's move to page 220, question 12. Okay, I have to do part A first before I do part B. There is a reason for it. So part A, we are talking about whether the game will be forfeiting the game or not. Okay, so you do the calculation. So now the question in part A, okay, that one you can do, have to forfeit the game. So the part 2, probability of, you want to forfeit the game. They say the team need at least 6 players to avoid forfeit. So for me, I define X as a number of players turn up for the game. So avoid. I write down first what I want to find. Avoid forfeit. Forfeiting the game. Because depend on the X that you define. So it will be probability X must be more than or equal to 6. Yeah, so this is equal to 1 minus probability of X less than or equal to 5. Am I right? Okay, everyone take out your graphic calculator and calculate 1 minus binom C, D, F. 9, 0.75, and 5. Okay, may I know what is the answer? Hurry up. Can someone give me the answer? Okay, 0.834. So now, have to forfeit the game. So I haven't answered yet. So therefore, probability of have to forfeit, because this is a void. Will be 1 minus 0.834, which is 0.166. Okay? Why I do it like that? There is a reason for it. Okay. So now, because I try to follow the question. Okay. So now for part B. Part B, I'm going to define another binomial. So I call it a Y. It's a binomial distribution. I'm playing 30 games. So the question said that how many games will you expect the team to forfeit? So probability of forfeiting a game that is a success, okay, is get from part A, that is 0.166. So now, how many games would you expect the team to forfeit? Expect means what? Mean. Or we call it EY. So is NP. So this is equal to 30 times 0.166. Then you get the answer. Are you clear? If I ask you what is the probability that they will forfeit more than 10 games, so then you calculate. Okay, 4.98. So when you talk about expected game, it's okay to put in decimal. It's okay to put in decimal. Okay? Are you clear? Can or not? Okay. So now, yeah. So I'm going to discuss. Okay. So today we want to, from now on, we are going to talk about continuous random variable. When you talk about continuous random variable, still remember what is random variable? Is what? Continuous random variable? It's a number process. Okay. It's a numerical value. Okay. And for continuous random variable is a measurable. Measurable variables. When you say measurable, so you can take a real value. So you can take any value in between. So it continues. So it's like, for example, I can have 5.999999. So actually, continuous variable, usually when we tabulate it, if we tabulate it, we will tabulate it in the form of a table. Okay, so this is the variable, this is the weight of a salmon in kilogram. Okay, look, so we tabulate it and here we put frequency. Yeah, so when you tabulate it, okay, they use this method. They use W between 3, then they put the equal sign here and they put less than 3.1 kg, correct? For we all, even you study O level or what, we hardly use inequality like that. We always use 3 to 3.0 to 3.09. Am I right? Then the next one we will put as 3.10 to 3.19. But they put it like that. So I just want to let you know the difference, the way they write and the way we write. Are you okay? So they are going to 2 decimal. So that is how. So we put it in a group data. So the more data that you have, the narrower the group will be. Okay, and we call this a class. Okay, that is what we have done in chapter 6, correct? Okay, so now can we use the mean and the standard deviation only to find the proportions of salmon that weigh greater than 6? They are asking you. Between 4 and 6, they are asking you. So if you have learned continuous variable in your high school, you will know that if it is a symmetrical, we call it the bell shape. So we name this as normal distribution. Yeah, correct? So then we will have a method to do it. And you will see this on page 231, that is the normal distribution. We will talk about it. So in most of the continuous random variable, if it is a naturally occurrence thing that is affected by many factors, usually is normally distributed, which means that God is very fair. Okay, what do you mean by normal distribution? What do you mean by not? So if you go back to your chapter 6, we will talk about the distribution. We have 3 types of distribution. We only talk about, there are more. This one, symmetrical, and the other one, okay. Now, can you give me A, B, and C, the name? Joshua, what is the name for A? A is positively skewed, or we call it skewed right. Okay, so this is definitely the mode. So we have the extreme value, the right extreme value for the variable. So these are called extreme value, or sometimes you call it the outlier. Okay, so that will draw the mean up. So the mean will be here. And the median will be here. Which means that I have less than 50% of the data that is greater than the mean. Agree? So that is what you mean by positively skewed. Okay, then if it's symmetrical, all the three central measures, they are the same. So this is called symmetrical, which is what is given in the opening problem. Okay, so C will be negatively skewed. Which means this is the mode. You have the lower extreme, but very few of them. So there are more than 50% of the data which is more than the mean. All right. Still remember what is the meaning of median that I told you? Okay, now for continuous variable. Okay, other than drawing the histogram, so if we want to really talk about a continuous variable, so we will use a function to represent the continuous variable. So exercise 8A, I expect you to do it by yourself. I'm going to straight go into exercise, going to probability density function. That is 8B. So it's impossible for us to list down the individual data. There are a lot. So it's continuous. So we use a function to represent it. And the function, we call it probability density function. So we are going to talk about 8B. Probability density function. Okay, I'm not going to go through all the investigation. You can go through it by yourself. Okay, now I'm going to straight to what is my probability density function. Okay, first of all, you have to define the value of the variable. Okay, range of variable. So like for example, if you look at example 2, the question X is your variable. Okay, X can be anything, I don't know. So the value can take from 0 to 3. So this is the whole thing that I'm going to talk about. So this is your so-called your population. Okay, these are all the value of X that I want to talk about. If I put in a number line, it will be from 0 included right up to 3. It can take in between. It can take 0.00001 and so on and so forth. Okay, so now I'm going to define a function. Okay, and this is called f(x) is given in example 2. It's called x squared over 9. Okay, now how am I going to know whether this is a valid probability density function. Okay, so next, first is the range, second is the validity of the probability density function that you have to check. We know that if you talk about proportion, if you talk about proportion, it means part of one whole. That is your population, correct? So first of all, you have to check for all values of x, fx must be greater than or equal to, okay, I should write it like that. Fx must be greater than or equal to 0, but less than or equal to 1. Agree with me? Or not necessary. Okay, less than or equal to. Agree with me? Part of the whole thing, fraction. So is this true for this case? So our smallest value of x is 0. So I put down there f0 is 0 squared divided by 9 or equal to 0. And all must be positive. So the best way is sketch the graph. Make sure the whole graph is above the x-axis. So you see the whole graph is above the x-axis for the defined. Okay, so this is the first criteria. Hello? Yeah. So that means if you are sketching the graph, you must make sure what? The probability density function. No need. You draw the graph can already. The probability density function must be above the x-axis in our case for all possible value of x. Okay, for all value of x, the probability, the function means the proportion. This function enable us to find the proportion for a particular value of x. I mean, indirectly talking about the, okay, that is called probability density function. So the proportion, I told you already, proportion is part of one whole. So it must be between 0 and 1. So if you plot the graph, make sure that the graph is above the x-axis for all value of x. If any part of the x is below the x-axis, that means that is not a valid probability density function. So this is the first thing that you must check. If this doesn't satisfy, we have to throw away the function. Are you clear? So every time you I give you a probability density function, you make sure you check this first. Okay, I may illustrate it a bit more by giving you other example so that you can understand better this part. Yeah, like for example, I say, okay, like for example, okay, for example, this is example, it's not what we want to talk about. Example, I have a probability density function of fx equal to cos x. And I say my x is between 0 and pi. Okay, 0 and 4, for example. Okay, so now I sketch the graph. Zero is here. Here is 1. Okay, then you go. So here is pi by 2. So now you go down. Okay, so here is pi. So therefore, I make a conclusion. Fx cannot be a probability density function because for x between pi by 2, I don't put include to pi, fx is less than 0. So this is an invalid probability density function. You get me? But if I change this one, I change to 0 to pi by 2, then can. Okay? So that is the first one that you have to check. Do you get me? Okay. Then second thing that you have to check. We know that when we talk about probability, yes. So now we know that if we want to find the probability, okay. So we say sum of all probability of all possible outcome. Outcomes must be equal to 1. Agree or not? In a discrete, we always write like that. Right? Sorry. We always write like this. Am I right? This is for discrete. Right? Am I right? So now for continuous, how? Like for example, our example there. Y equal to fx equal to x squared over 9. So how am I going to find sum of these? And we learn in chapter 4 that when you sum up all the possible, correct? We can replace with This sign, am I right? Because you have infinite sum. So from 0 to 3, fx dx, what must I get? What must I get? Must be 1. If it's not 1, then it's not a valid probability density function. Do you get me? So every time when you are given a probability density function, first of all, listen, because it's a continuous variable, so we use a function to represent the proportion. And the chances for a particular value of the variable to happen, we will say that is almost negligible. Impossible. The probability almost equal to 0. Afterward, I will show you why. Okay, first, we have to check. Is the whole graph above the x-axis? Second, okay, you have to come in this order. You don't jump the order. You have to come in this order. First, check, is the whole graph above the x-axis? If yes, then we have to make the second check. Is the sum of the area bounded by the curve is equal to 1. Because the area bounded by the curve or probability density function represent the probability of a particular value of a range of value to happen. In continuous variable, so after you understand this, you know that for a continuous variable, probability for x equal to r is 0. Agree with me? Why is it 0? Because if you do integration from r to r, what do you get? You get 0, am I right? So that is what I mean by the chances of one particular value of a continuous variable to happen is equal to 0. So two-way, not two-way, two procedure. That's why if you want to be a doctor, you must know the procedure. You cannot jump the procedure. That's why a doctor must be very good in maths, because you know the procedure. Yeah. So the first is do this checking first. If this is okay, then go to the next one. That is this one. So now you take out your graphic calculator, you key in, see whether you get 1 or not. Then it's a valid probability density function. So you see in your book, you also do like that. Am I right? Hello? Is it okay? Yeah. So I repeat, first of all, key the probability density function into your graphic calculator, into the function key, then follow this formula to get the expected outcome, the mean. Okay, 2.25. Okay, someone get it 2.25. If wrong, please correct. Okay, then we know that we also have to find the standard deviation, correct? So the standard deviation formula will be square root of integrate 0 to 3. That is the variable. The x, you just type in the x. Hello? That means you type this into your calculator, FNINT. Then it will come out like that. You key in 0 here, key in 3 here. You key in x, then you key in y1, then dx. Are you clear? This is the formula to find the mean. Okay, to find the standard deviation, so you got your mean already, correct? 2.25. Okay, so it will be 0 to 3 x squared fx dx. Take away the mean square, 2.25 square. So that means you key in your calculator, you key in FNINT, then you got this come out, you key in 0, 3, you key in x squared y1 dx. You see, you don't have to. Okay, can I have the standard deviation? Can I have the standard deviation? The x is a variable. .17. So class, formula very important. Okay, these two formula. Okay, now how to find median? Okay, if there is only given one function, 0.581, who is right, who is wrong? Which is correct, 0.581 or 1.77? Class 1.77. So 0.581, please do the changes. This is the formula to find standard deviation. You don't tell me where the x squared comes from. Isn't it when you do the discrete random variable, when you do the discrete, isn't it sum of xi squared times by pi? Pi is your fx, okay? So this is your x squared. That is how you go together with the, and this one you replace with integration. Hello? Don't keep asking me where the x squared comes from. That is how you do the one. That is how you compare with discrete random variable. For continuous, you use integration. This is the formula to find standard deviation. Is that okay? Hello? For discrete, isn't it? You do like that. So that is how you compare. Because continuous, you have to, there are a lot in between. So this sum, you sum out, you find the sum of infinite. Hello? Can or not? So how to find the mean, how to find the standard deviation. Next, I'm going to teach you how to find the median. Okay, so third, What do you mean by median? Can someone give me the meaning of median? 50% of the data is more than that value, or 50% of the data that is less than that value. So median, we let it be M. Okay, so which means that the probability, our X is from 0 to 3. Okay, so that means if I integrate from 0 to M, I find the sum of the probability. This is my median. So this area must be 0.5. Agree? Agree? Okay. So to M, so the probability density function is Fx. Must be equal to 0.5. Okay, this one, still another person got 0.58. Can someone clarify this? Are you all using your calculator and calculate? So can someone verify whether which is the correct answer? Is it 1.178 or 0.58? I tell you what, if you don't want to use calculator, this part you sure flunk. I'm telling you, 10 marks. You don't want to use calculator and try now, you sure flunk. So this is a wrong answer. So please, please, please try. So 0.581 is the correct answer. Please go and check it by yourself. Okay, now I can do it like that, or I can also say that from M to 3, this area is also 0.5. Correct? So now, either one of it. So now you take out your graphic calculator, you go to your solver. You have your solver, numerical solver. You key in E1, you do your FNINT 0 to X, Y1 dx equal to, okay, now equal to. And E2, you put 0.5. Okay, then you enter. You know that your value of N must be between 0 and 3. So the X that come out, you can put 2, 1, up to you. Then you take out your, you put alpha, enter. Then your calculator will calculate for you. For this case, you key in your E1 as integrate from X to 3, Y1 dx. And here you put 0.5. So you do the same thing. Yeah, may I know what is the answer? So either way can work. Can someone give me the answer quick? I have next class to go to. Is it 2.38? So median equal to 2.38. Our mean just now is what is the mean just now? 2.25. So this is skewed left. And the mode is 3. See or not? So everything we use graphic calculator to do. Try exam or final, maybe you need to integrate because that include every single thing. So I will try to cut down all the, not try, totally no integration, but you must know how to use your graphic calculator to get the answer. Got it? Okay. So you better try your exercise 8B.1 and 8B.2. So tomorrow I will talk a bit more about this. Okay. Yeah. Thank you, class.